Hello, my name is Sharifuddin AISA bin Ahmad and I'm going to talk about the background of the project. This project depicts the utilization of interpolation strategies in designing by creating the issues proclamation which is expected to eliminate utilization of interpolation method. In arithmetic, interpolation is the assurance or assessment of estimation of the capacity function from the specific estimation of the capacity itself. The Lagrange interpolation equation is an approach to locate a polynomial which takes on specific qualities as subjective focuses. Next, I'm going to talk about the problem statement. Fisheries and hydroponic play a significant, however regularly overlooked part in financial matters far and wide in both creator and non-industrial nations. While catch fisheries are essentially not the same as the other food production system in their linkage and reaction to environmental change in food security result. Many fish populations relocate over significant distance going through differential regional water. This makes issues of transboundary debate driven by common habitat factors. Environmental change effect could change asset access, time and washout at both network and national level. Then I will talk about the objective of this study. For the objective of this study, firstly, to gauge the precise estimation of capacity for the normal ratio needed by using linear and quadratic Lagrange interpolation. Next, it is to locate the outright mistake for both technique, which is normal ratio method and Lagrange interpolation. After that, it is to figure the surmise estimation of capacity for normal ratio method by utilizing the Lagrange interpolation method. Finally, it is to locate the absolute error for both method, which is normal ratio method and Lagrange interpolation method.
Assalamualaikum and selamat sejahtera. I will present about the literature view in chapter 2. For introduction, during this project, the knowledge applied is numerical method, which is interpolation, to work out the value of the temperature using the order Lagrange interpolating and its absolute relative approximate error. The definition of numerical method is numerical is an algorithm of the problem of mathematical analysis use numerical approximation. Numerical methods are used to approximate the solution to a problem whose analytical is not available or non-analytical solution can be generalized. So, the importance of numerical method is first, to find application entirely in engineering in the life of science, social science, medicine, industry, and even the humanity. Second, to provide how to unravel problem quickly and simply compared to analytic solution. Third, as a cornerstone of the mathematical modeling scene, most model word problem fail to possess analytical solution. Fourth, demands of knowledge such as interpret the behavior of expected solution or algorithmic aspect concerned with the selection of the numerical method. And the last one is to provide approximate solution within specific limit error rather than concrete symbolic answer. The definition of Lagrange interpolation is Lagrange polynomial is another form used for polynomial interpolation. It is called a form because with a given set of distinct points, the interpolating polynomial is unique. Interpolation is one among the techniques in mathematics to unravel mathematical equations that are difficult. As you can see on the right of the slide, there is two general bases of Lagrange polynomial interpolation. The definition of thermocline is the water layer, which is water temperature decrease rapidly in increasing depth. The depth and cover above the range of thermocline changing based on season. As you can see on the right of the slide, there is a picture of the changing of temperature following the depth based on the season changing. This is the filler table for this project. First of all, we must understand the application of numerical method in engineering problem. From this fact, we create the idea of method that have in numerical method such as Lagrange interpolating method. From this idea, we create the issue. What is Lagrange interpolating? Then, we must take action by understanding the problem and make literature study about the problem of statement. Second fact is study about the problem which is change in temperature for a lake. Then we create the idea by determine by using the numerical integration. From this idea, we create the issue. Which method to find the area and volume in numerical integration is most accurate? Then, from this issue, we must find information through book and internet about the problem and understanding the problem. And the last fact for this filler table is analyze the value of the temperature and its absolute relative approximate error. From this fact, we create the ideas by calculate by using third order Lagrange polynomial. From this idea, we create the issue. How third order Lagrange polynomial can be used in the change in temperature. From this issue, you must take action by refer the lecture note of Mathematics Engineering Civil 4 and make a discussion with all group members.
Assalamualaikum warahmatullahi wabarakatuh and good morning to our lecturer. My name is SITI binti MOHARAM and I would present the chapter 3 methodology part for our project. For introduction, based on real life, there may be certain range of data set that needs to be estimated to find the corresponding value for an intermediate value which is not in the data set. In order to do so, interpolation techniques needs to be take part to provide the approximation in constructing new data points within the range of discrete set of known data point. So based on our problem statement, this is our table of data, set of data, temperature versus the depth for the lake. So based on the data set, using the data given, we see the largest change between the temperature is between the depth of -8 meter and -7 meter, which is here 17.6 degrees Celsius and 11.7 degrees Celsius. So therefore, this present study proposed the use of Lagrange interpolation method to determine the value of the temperature at 7.5 meter and the position where the thermocline exists is given. Drafted figure and calculation. Okay, for the third order Lagrange polynomial interpolation, or also called cubic interpolation, the temperature chosen given by based on the table set of data. Okay, since the temperature needed to be found is at Z equals to -7.5 meter, the 4 data points that are chosen must be closest to the Z equals to 7.5 meter. That also brackets the 7.5 meter depth. So evaluate it. The 4 data points are -9, -8 meter, -7 meter and -6 meter. Therefore, this is the 4 data points that we are gonna be used in this calculation. And from this data that we have stated here, we're gonna use this formula in order to complete the calculation. So we have calculated the temperature for the 7.5 meter depth by using the Lagrange polynomial interpolation, and the answer and the temperature for the 7.5 meter is 14.725 degrees Celsius. For the absolute relative approximate error obtained between the result from the second and the third order polynomial, and we gain the absolute relative approximate error is 3.9898%. So in order to find the position of the thermocline, the point of inflection of the third order polynomial must be calculated based on this equation. And this is our calculation process. And this is the continuous for the calculation from the previous slide. And we proceed by simply setting this expression equals to 0, and we get the z equals to negative 0.5638 meter. From this answer, we can verify that the fact it falls within the specific range of the third order polynomial, and it also falls within the region of the greatest temperature change in the collected data from the lake. That's all from me. Thank you.
Hi, my name is NOOR SHARIFUDDIN binti ZULKIFLI, and I will present on chapter 4. 4.1 is discussion. Based on the study of the sudden change in temperature, problem can be solved by using Lagrange interpolating polynomial. From the given temperature versus depth data, it has been analyzed by constructing the polynomial using third order of Lagrange polynomial formula. 4.2 is the summary of the discussion. From the calculation, the absolute relative approximate error obtained between the result from the second and third order polynomial is 3.9898%, while the position of the thermocline is at negative 7.5638 meter. It is accepted as it falls between the range of negative 9 and negative 6.
Assalamualaikum warahmatullahi wabarakatuh. My name is Saiful. I will talk about the conclusion for the project. Fish need dissolved oxygen to survive, so the layer of the water below the thermocline become a dead zone as the air temperature rise. Based on the quantitative analysis, it can be concluded that the calculation procedure presented here may be useful for determining the actual position of the thermocline in a lake. The ideal position of the thermocline is around 6 meter to 9 meter deep. By using the Lagrange polynomial integration, the best position of the thermocline at depth is at depth 7.5638 meter deep in the lake. In this case, fishermen must cast their net at that depth to boost the catch of the fish in the lake. Thank you.